Before approving the schedule, the project manager can run a Monte Carlo simulation. Monte Carlo analysis is a quantitative risk analysis technique. In the schedule management context, it is used to assess schedule risk, answering questions such as: what is the likelihood of finishing the project within a specific project duration? What should be the project duration to ensure a specific level of confidence? And how much time do we need to add to the project as a contingency reserve to ensure a specific level of confidence? Monte Carlo is based on the simulation of multiple project iterations. Each iteration generates a duration for all project activities, using as an input the optimistic, most likely and pessimistic estimates issued by the team. Each iteration will then aggregate those activity durations into an overall project duration, according to the dependencies of the network diagram. By completing multiple iterations, the Monte Carlo analysis can calculate the probabilistic distribution of the project duration. Let's apply these concepts to a simple example with 4 activities. Before initiating the simulation, the project manager prepared a network diagram and collected optimistic, most likely, and pessimistic durations for each activity. The estimates were collected in weeks. The Monte Carlo simulation will be run 1,000 times. On the first iteration, the method returned 5, 4, 7 and 2 weeks as the duration estimates for A1, A2, A3 and A4. As a result, the estimates were then aggregated into an overall project duration of 14. The overall duration was obtained by adding the duration of activities A1, A3, and A4. The duration of activity A2 was disregarded because it was not on the critical path. On the second iteration, the method returned 3, 3, 7 and 3 weeks as the duration estimates for A1, A2, A3 and A4. The estimates were then aggregated into an overall project duration of 13. The process was repeated multiple times. For each iteration, the model returned estimates for each activity and an overall duration. The final results were combined into a frequency chart, counting the number of occurrences of alternative duration ranges. As you can observe in the next figure, the durations that occurred more often were 13, 14, 15, and 16 weeks. The potential outcomes were also represented in a probabilistic distribution, showing the likelihood of each duration. The project manager can now determine that there is a likelihood of 0.1% of completing the project within the current scheduled duration of 8 weeks. To raise the level of confidence to 99.9%, the project duration would have to total 20 weeks. This video was developed by XPM Consulting. XPM is a project management, agile, ITIL and leadership training company. Thank you for watching. We hope you found the video interesting, and if you did, don't forget to click the like button and subscribe to our channel.